Microplastics are everywhere. They are discussed in water, food, air, clothing, packaging, and household dust. The internet gives you one message: panic. But panic is not science. The better question is simpler. What do we actually know, what remains uncertain, and which habits are worth changing? Begin with the Feynman question. What is a microplastic? It is not a mysterious invisible poison with one fixed shape. It is a small plastic particle. Different plastics have different sizes, forms, chemical additives, sources, and behaviors. One word hides a complicated family of materials. Some microplastics are small enough to require a microscope. Nanoplastics are smaller still. Size matters because a large fragment may behave differently from a tiny particle. The smaller the particle, the harder it may become to detect, measure, and study accurately. Some plastic particles begin small. Others form when larger products break into smaller pieces over time. A plastic bottle, food wrapper, synthetic fabric, or tire does not disappear when it wears down. Some of the material becomes smaller and harder to see. Plastic is convenient because it is durable, but durability has a cost. A material designed to resist breakdown can persist in the environment. Larger pieces fragment. Tiny particles travel through water, soil, air, and ecosystems. The environment keeps the receipts for products we throw away. Exposure is not only about drinking water. Tiny particles and fibers may also travel through air and dust. Synthetic textiles, built environments, and outdoor pollution can contribute. You may never see the particle, but invisibility does not mean the pathway is impossible. Microplastics have been reported in foods and beverages, but detection alone does not prove harm. Finding a particle answers one question. Is something present? It does not automatically answer the next question. At this amount, does it cause disease? Bottled water has become a major focus of public concern, but the practical lesson is not to become afraid of drinking water. Hydration still matters. When safe tap water is available, a reusable bottle can reduce dependence on single-use plastic without turning your daily routine into a panic exercise. This distinction matters. Presence is not the same as risk. A substance can be detectable at a tiny level without causing measurable harm. Risk depends on the particle, dose, route of exposure, frequency, duration, and biological response. The word detected is only the beginning of the investigation. Measuring microplastics is difficult. The particles are small. Plastic is already present in laboratories, clothing, tubing, packaging, and the surrounding environment. Researchers must work carefully to separate the true signal from contamination and false positives. Good science is not embarrassed by uncertainty. It measures uncertainty. Researchers need standardized definitions, reliable reference materials, careful sample collection, and strong quality controls. Better tools lead to better questions, better answers, and better decisions. You may have seen dramatic headlines claiming that plastic has been found in blood, organs, lungs, reproductive tissues, or the brain. Some studies have reported particles in human samples, but the exact quantities and health implications remain uncertain, and some findings are being questioned. There are real reasons to study microplastics carefully, but concern is not certainty. Responsible communication avoids two extremes. Do not pretend the issue is meaningless. Do not pretend every disease has already been explained by plastic exposure. Laboratory studies and animal studies can reveal possible mechanisms. They help researchers decide which questions deserve attention, but they are not the same as proving a health outcome in people living ordinary lives. A clue is valuable. A clue is not a conclusion. The dose matters. The route matters. The size matters. The duration matters. This is basic toxicology. A dramatic microscope image can attract attention, but it cannot replace exposure measurement and careful risk assessment. Plastic particles and chemicals associated with plastics are related topics, but they are not identical. A particle may contain additives or collect substances from its environment. The health question becomes more complicated because the material is not always one simple ingredient. Synthetic clothing can shed fibers during production, wear, and washing. Your wardrobe is not the only source of microplastics, but it is a useful example. A familiar product can release tiny fragments gradually without looking damaged. Tires also wear down. The road does not only collect visible dust. Friction releases small particles over time. This is why microplastics are not merely a personal shopping issue. Transportation systems, product design, and infrastructure also shape exposure. Food packaging is another practical area to examine. You do not need to discard everything in your kitchen overnight. Begin with the easiest improvement. Avoid heating food in damaged or unsuitable plastic containers when a safer alternative is available. A healthier routine should reduce anxiety, not create a new obsession. You do not need to inspect every object in your home under a microscope. Focus on realistic substitutions. Reduce unnecessary single-use plastics. Avoid heating unsuitable plastic. Replace worn containers gradually. Every concern eventually becomes a product. Plastic detox tea, plastic detox supplements, plastic detox cleanses, expensive kits. But before buying anything, ask the Feynman question: which particles does this remove, through which mechanism, and where is the evidence? No drink has been proven to erase your total microplastic exposure. A green label does not convert uncertainty into evidence. Be cautious whenever a company uses a real environmental concern to sell an easy internal cleanse. Some wellness discussions now include expensive blood cleansing procedures. Early research may create headlines, but a lower measurement after procedure does not automatically prove better health, lower disease risk, or longer life. A number can change before the larger question has been answered. A headline is not a prescription. A medical procedure can have risks, costs, and appropriate clinical uses. Do not turn emerging research into a self-prescribed longevity treatment. Evidence must answer whether an intervention meaningfully improves health, not merely whether it changes a laboratory result. The first filter should be mental. Notice when a video is selling panic. Does it name the study? Does it explain uncertainty? Does it distinguish a particle from a chemical? Does it tell you what is known, what is suspected, and what remains unproven? Drink safe water. The best choice depends on local water quality. A reusable bottle can reduce single-use plastic waste. A suitable filter may be useful in some situations, but no one device solves every water quality concern. Match the tool to the actual problem. Indoor dust is another practical target. Ventilate when appropriate. Clean surfaces. Vacuum where practical. Wash hands before eating. You do not need an extreme protocol. Ordinary housekeeping can reduce many types of dust exposure while supporting a healthier indoor environment. When practical, use glass, ceramic, or another suitable material for heating food. Replace heavily scratched or damaged containers. Do not assume that every plastic product is identical. Follow product instructions and make gradual changes where they're easiest. Perfection is not realistic. Plastic is built into modern life, but reduction still matters. Carry a reusable water bottle. Reuse a suitable food container. Reduce unnecessary disposable products. Small changes become meaningful when millions of people repeat them. Do not stop eating nutritious foods because of fear. Wash produce normally. Eat a balanced diet. Do not replace vegetables, fruit, legumes, and whole grains with a restrictive plastic avoidance routine. A health strategy should not create a new nutritional problem. Personal habits matter, but individuals cannot solve plastic pollution alone. Product design matters. Waste systems matter. Industrial practices matter. Textile production matters. Transportation matters. Regulation matters. The solution must be larger than a shopping list. Even while human health research continues, plastic pollution is already an environmental problem. Tiny plastic fragments move through ecosystems and are difficult to remove once released. Preventing pollution matters before every medical question has a final answer. Try a realistic 7-day experiment. Use a reusable bottle. Avoid heating food in worn plastic. Wash produce normally. Clean indoor dust. Replace one disposable habit. Do not buy a detox product. Do not attempt to redesign your entire life in one afternoon. Look at your ordinary day. Where does plastic appear repeatedly? Bottled drinks, takeaway packaging, microwave containers, disposable cups, synthetic textiles. Choose one or two changes that are practical enough to become permanent. Now audit the claim. What was measured? How accurately? In which people? At what dose? Was a finding repeated? Does a study show presence, association, or causation? The Feynman method is not about accepting simple answers. It is about asking precise questions. Fatigue does not prove microplastic toxicity. Brain fog does not prove microplastic toxicity. A difficult week does not prove microplastic toxicity. Persistent symptoms deserve proper medical evaluation. A trending environmental topic should not become a universal diagnosis. Avoid both extremes. Do not panic. Do not dismiss the issue. Support better research. Reduce avoidable waste. Choose practical substitutions. Ask for stronger evidence. Good science is not passive. It is careful. Here is a Feynman test. Can you explain the issue in one sentence? Try this. Microplastics are widespread environmental particles. Exposure is plausible. Health effects remain uncertain. And reducing avoidable plastic waste is a sensible response. Your goal is not a plastic-free fantasy. Your goal is a more thoughtful routine. Reduce unnecessary single-use products. Avoid avoidable heating in plastic. Maintain a balanced diet. Clean normally. Support better systems. Let evidence guide concern. Microplastics are everywhere, but panic is not a plan. Do not buy fear. Do not buy miracle detoxes. Ask better questions. Make realistic changes. Support better research. Reduce unnecessary exposure where practical. And remember, uncertainty is not a reason to panic. It is a reason to think carefully.